Now, today's lesson, we are going to look into solutions, okay, and suspension. I think if you can recall, I think the students who were here previously, we did talk a little bit about homogeneous and heterogeneous, right? These mixtures. So what are they? In fact, for the homogeneous mixture, we call them solution. Heterogeneous, we actually call them the suspension. Okay, so I will start off just by going through some notes first. Okay, so lesson outline for today. Okay, Heidi is here, hold on. Now you need to understand the terms solute, solvent, and solution. So each of them play a different role when we come to mixing things together and forming something else. Okay, so you need to also deduce the nature of solutions and suspension by simple lab tests. A very easy one is actually to use torch. Yep, if you shine the torch onto the solution or suspension, you get different results. Okay, so that is a very, very good way, right, to tell whether what you have is a solution or suspension. Of course, there are other ways to do it, like carry out certain separations, such as filtration. But before we can go into the separation techniques, okay, you need to understand solution and suspension first. Yeah, once you master this section, it will not be too difficult for you to start off with the separation technique. If you ask me which chapter we are at now, this is linked to chapter 4. Okay, so we have already finished chapter 1, 2, and 3. Okay, maybe the students over here, okay, doesn't matter whether you are new or whether you have been with me for a while. Can you type into the chat what is the topic your school is doing at the moment for science? Total, you have 8 topics, 8 chapters. Evan, you are same as me, right? Doing solubility already. I know some schools are very fast. Some schools even started on separation. Okay. So if you need to refer to your textbook, it's fine, no? Just take your textbook and then do it. Oh, Savika, same as us. Good. Yeah. Which is a good thing if you are going at this pace, like Evan as well as Savika, right? It's safe. Okay, it's safe for you to be at this pace as the tutorial. Certain students say that, oh, it's a bit too fast. Their school is still doing it very slow. So I can tell you, right, for schools who are not doing solution and suspension now, at the end of the year or towards the later part of the year, right, the teachers will be rushing through the topics, okay, rushing to finish teaching. So when you rush to finish teaching, students cannot learn very well. So I have planned out the whole syllabus for the whole year. I know this is the correct pace. Okay, Angel, you have not typed in yet, so I don't know what topic your school is doing now. Yeah. Okay. Anuja, you're still at physical properties? That is chapter 2, right?
Yeah.
Oh, I am very scared for you, because if you're still doing chapter 2, it is very risky. Oh, so your school took so long to finish up the chapter 1. I see. All right. Okay. Angel school is doing elements, mixtures, compound. Heidi, you are finishing up on elements, mixtures, compound, right? I hope so. Good. Yeah, you should be starting on solution suspension so that you can do the separation technique. So Angel and Heidi still not so bad. But Anuja, I am very concerned about the speed, okay, that your school is going. Never mind, we can chat later. Okay, now the next thing you need to learn also is the factors that affect solubility as well as the rate of dissolving of substances. Okay, rate of dissolving, you can imagine things like maybe we add sugar to coffee, right? So think about how to make the sugar dissolve faster. Do you use ice water or do you use hot water? Okay, so there are ways, right? Yeah, you learned this in P5. Yes, correct. Because in P5, some of the teachers would have taught you things about surface area. Yes. So your teacher might even use this dissolving as an example to show you how surface area actually helped to dissolve things faster. Yeah. And then you can link that to digestion. Okay. Big pieces of food versus small pieces of food. Yeah. So I know what you mean, Elliot. So the rest of you, if you can recall, you have actually learned something like that before. Now let's start off with solution. Okay, I'm going to introduce these three terms to you: solute, okay, solvent, and solution. When you look at these three terms, very simply, we dissolve solute in solvent in order to get a solution. Can you see that? So solute will be these blue crystals here in this example. Okay, the solvent here likely is water. Okay, when I pour the solute into the solvent and then I stir it, let it dissolve. Okay, and I see that the solute actually dissolves completely. So I get a solution. This is a light blue solution. Now, the substance that dissolves is known as the solute. And the substance, okay, the substance that the solute dissolves in is called the solvent. And the resulting mixture is the solution. Now, a solution has all the components evenly mixed. So this is something that you must keep in mind for solution. Okay, so the components inside are evenly mixed. So that means these blue crystals, it's actually found evenly mixed throughout this water. Yeah, so you don't see some parts being darker blue, some parts is not as blue, etc. It is the same color throughout. If you are copying notes, please do not copy notes because I will be sending you these slides. Okay, during break time, you will get the slides from me. All right, so the most important thing is you listen first. Can? Now, a solution definitely will contain solute and solvent. Okay, there are three types of solutions. Okay, let's talk about dilute solution. Now, if you have a dilute solution, that means, for example, I have a lot of water in this case, a lot of the water, then very little blue crystal. That will give me a very light blue colored solution, right? So that is called diluted. You can also apply it to maybe dissolving sugar in water. So I have a big glass of water. I put in maybe half teaspoon of sugar. That is called diluted because very little sugar is added. Now, I can have also concentrated solution. So that means if I am representing it with like the sugar and water, same glass of water, all right, then I put in maybe this time round, not half teaspoon, maybe 20 teaspoon of sugar. That's a lot of sugar, right? So I can get a concentrated solution. Okay, so it's going to taste very sweet. Now, the next type will be called the saturated solution. Saturated solution means I add the sugar in, I add until the sugar cannot dissolve anymore. Okay, can no longer dissolve. So they say here, maximum amount of dissolved solute, okay, in a given amount of solvent at a certain temperature. So given amount of solvent, I was using water, 1 glass of water, right? Then temperature is room temperature. I didn't say I heat up, I didn't use hot water. Okay, I only say I use water. So whenever I say that, it is room temperature. So that is the maximum amount I can dissolve in. Maybe it could be 32 teaspoons. I don't know. I've not tried it. Yeah, but that is the meaning of saturated. Is that okay? All right, can I understand this part? Good. So when a substance dissolves in a solvent, we say that it is soluble. So this term soluble, okay, it just simply means can dissolve. All right. So like sugar is soluble in water. So sugar can dissolve in water. Yeah. So be familiar with all these terms now. Water is actually a universal solvent. Why is that so? Because there are so many substances that can dissolve in it. So that's why they just give it a name, water universal solvent. Now, anything that is dissolved in water, right? The resulting solution is known as the aqueous solution. Yep. So if you see this term, you must understand that the solvent used is water. Now, aqueous solution will come in very handy when you move up to higher levels. Okay, I think especially in Sec 3. Because when you write down the equations, right, you need to also indicate whether that product is in solid state, liquid state, aqueous state, or is it a gas, something like that. So this will come in very useful later on. Now, alcoholic drinks. Yeah, alcoholic drinks. So we dissolve, alcohol with water. Okay. Alcoholic drinks is not 100% ethanol. If you have 100% ethanol and you drink it, you might die very easily. Okay, too concentrated. If you take a look at the alcohol content of the alcoholic drinks, have you all done that before? Never. Okay, do you all have like alcohol at home? Does your father or your mom keep alcohol at home? Yeah. Do I have no wine, no beer? I have wine, I have beer, I have hard liquor, all in the storeroom, So only when guests comes, then we will take out the stuff and, serve the drinks, drink together. Yeah. So the alcohol content for beer is different to that for wine. Okay. Also very different to that of the alcohol, hard liquor, like the whiskey, maybe like the Martell. You can also talk about vodka. So all these have different alcohol content. If you have the alcohols at home, go and take a look. It will be indicated on the label. Yeah. So when they have this much alcohol, then it also tells you what is the rest of the components there. Mostly will be water. Can? Now, nature of solution. When a solution is formed, okay, solute particles are evenly and completely mixed with the solvent particles. This is something that you have to know now and even, throughout the whole of your secondary school days, I think. Yeah. Okay. So you must know how to explain it. Now, let's say we have solvent mixed together with the solute. Okay, initially, when I just put the solute into the solvent, of course, I have certain concentrated parts of it, of the solute, isn't it? After I stir, okay, and the solute dissolve, then I can get something like this, okay? It's evenly mixed, so you have all the particles mixed throughout the entire solution. You don't have one side of it having more of solute or more of solvent. Clear? They will distribute very nicely, evenly throughout. Okay, so this term, evenly, very important. Now, the next thing also, take note, we call solutions homogeneous as well. Why call it homogeneous? Because homo means same. Yeah, homo means same. So the physical color properties are the same in every part. One example here you are seeing now on the slide is this iodine. Iodine that is dissolved in alcohol. What do you see about the color? It is evenly distributed. So the physical appearance, the color, the evenly distributed. You don't see corners that are darker. Here looks darker because of the curved part, the curvature of the beaker, not because there is more iodine there. No. Okay. Even if I leave this to stand, that means I leave it on the table for a couple of hours. You don't see anything changing here. The color still stays the same throughout the entire solution. When I try to shine light through the solution, okay, light passes through. Can you see that? So light passes through solution. So this is one way of testing for solution in the science lab. Why is that so? Because the solute particles having dissolved into the solution already, right? They are too small to block the light. Okay? They are too small to block the light. Now, suspension. Suspension is the opposite of solution. Okay, a mixture that contains insoluble solid particles suspended in a liquid.